Life is just full of puzzles, right? From simple games to really big decisions, we're always trying to figure out the odds of things. Well, it turns out probability isn't just some abstract math class concept, it's actually a practical set of tools for solving those exact puzzles. And today, we're going to open up that toolbox.
So, let's kick things off with a classic card puzzle. This will get us thinking about how you handle situations where there's more than one way to get what you want. Is it really as simple as just adding your chances together, or is there maybe a little catch we need to watch out for?
Okay, but what happens when one thing happens right after another? Does that first event change the odds for the second one? As we're about to see, the answer to that question is the key to cracking a whole different kind of probability puzzle.
And then we get to the really powerful stuff. This is all about how we update what we think we know when new information pops up. This isn't just for puzzles. It's at the core of how we learn from everything around us.
And here's the best part. You don't need magic to solve any of these. In this explainer, we're going to give you 3 super powerful, totally logical tools that will help you solve not just these specific puzzles, but a ton of others you'll bump into.
All right, let's pop open this toolkit and grab our first tool. Think of this one as your OR tool. It's absolutely perfect for any puzzle where you're looking for one outcome or another one. So, let's start with a puzzle from our source material. Picture this. You've got a bag with 12 balls inside, some white, some black, some red. We win if we pull out a white ball or a red one. So, how do we figure out our chances?
Now, the secret here is a simple but super important idea called mutually exclusive. It sounds fancy, but all it means is that two things can't happen at the same time. A ball can't be white and red. It's one or the other. And knowing that makes the math incredibly simple.
Because these events can't overlap, we can use this simple addition rule. We just take the probability of drawing a white ball, that's 4 out of 12, and we literally just add it to the probability of drawing a red one, which is 5 out of 12.
And that gives us a grand total of 9 out of 12. A little quick math, and that comes out to 0.75. In other words, we have a 75% chance of winning this little game. It's a really simple rule for a pretty powerful result.
Right? That was easy enough. But what happens when the things we want aren't so separate? What if they can actually overlap?
And this card puzzle is the perfect example. We're looking for a heart or a king. But wait, there's a catch, isn't there? Unlike the colored balls, one card, the King of Hearts, is both of those things at the same time. If we just add the probabilities like we did before, we're going to end up counting that card twice.
So how do we fix this? Well, the solution is just as logical. We start by adding the probability of a heart, which is 13 out of 52, to the probability of a king, which is 4 out of 52. But then, to fix our double counting problem, we simply subtract the probability of that one overlapping card, the King of Hearts, and that leaves us with the right answer, 16 out of 52.
All right, time for tool number 2. This is our AND tool, the multiplication rule. It's designed specifically for figuring out the probability of one thing happening and then another thing happening right after it.
Let's start with a coin toss. Super simple, right? The chance of getting heads on your first flip is 1 in 2. And the chance of getting heads on the second flip is also 1 in 2. We call these independent events.
And this is the core idea of independence. That coin has no memory. It's not thinking, oh, I was heads last time, maybe I should be tails now. The first flip has absolutely zero impact on the second one. And when events are independent like this, we just multiply their probabilities together. So 1/2 times 1/2 gives us a 1 in 4 chance.
But here's where it gets interesting. Not all sequences are independent. Just look at the difference here. If you draw a king from a deck and then put it back, you've reset everything. The odds for the second draw are exactly the same. But if you draw that king and keep it in your hand, well, you've changed the game. The deck is different now. It only has 51 cards and only 3 kings left. The second event now depends on what happened first.
So, to figure out the odds of drawing 2 kings without putting the first one back, we multiply the odds at each separate stage. The probability of getting that first king is 4 in 52. Then we multiply that by the new probability for the second king, which is now just 3 in 51. And that gives us a way smaller probability, just 1 in 221.
Okay, it's time for our final and most powerful tool. Let's get to the master key, the big one. This is Bayes' theorem, and it's all about how to get smarter by using new evidence to update what you believe.
Now, I know that sounds complicated, maybe even a little scary, but forget the formula for a second. At its heart, it's just a logical way of describing something we humans do all the time. We change our minds when we get new information. It's just the science of learning from experience.
You can really think of it as a three-step dance. First, you start with what you think you know, your initial belief. Then you get a new piece of information, a new clue. And finally, you combine those two things to form an updated, smarter belief. Okay, let's put this into practice with a factory puzzle from our source. A company has 2 scooter plants. Plant I makes a whopping 80% of all their scooters, and Plant 2 makes the other 20%. Now, we find a random scooter and we see that it's standard quality. So, where did it most likely come from?
So check this out. At first glance, you'd probably think there's an 80% chance the scooter came from Plant I, right? Just based on how many they make. That's our starting belief. But now we get a new clue. We learn that Plant I is more consistent, making standard quality scooters 85% of the time, while Plant 2 only hits that mark 65% of the time. Bayes' theorem lets us merge these facts. The clue that our scooter is standard quality makes it even more likely that it came from the more reliable plant. And that new evidence updates our belief, pushing the probability up from 80% to 84%. We just got more certain, thanks to new information.
And just like that, you've got a whole new toolkit. These aren't just for solving textbook problems. They're frameworks for thinking more clearly and making better decisions out there in the real, uncertain world.
So, let's do a quick recap. It's all about picking the right tool for the job. If you're looking at an OR puzzle with different choices, you'll grab the addition rule. If you've got an AND puzzle with things happening in a sequence, you'll want the multiplication rule. And whenever new information comes along, it's time to pull out your update tool, Bayes' theorem, to make your beliefs that much sharper.
This toolkit really helps you see the hidden patterns and the math that's all around us. So the final question isn't about cards or scooters anymore, it's about you. What everyday puzzle, what little bit of uncertainty in your own life are you going to look at differently now that you have the tools to solve it?